Greetings, Kool-Aid Jammers and Team Elmo, to a Freaky Friday Furlough video lesson. It's the day before Halloween and it appears that something strange has happened. There we go. Much better. Moving right along, today we're going to be reviewing a little bit of science. If you have not already, I want you to answer number 1 through 4 in your packet about seafloor spreading as a review. So pause the video now if you haven't answered the questions yet. Now let's take a look at number 5. How is seafloor spreading related to continental drift? This question is a little more complex, so we make sure we understand all the parts of the answer. So basically, seafloor spreading is when magma comes out of the mantle when there's a crack in the crust. This new mantle material, right, it's really hot, so it rises to the surface, and it's going to push away all the old crust that's around it. So the magma rises and it pushes away the old crust that's around it. That old crust, right, moves apart, the seafloor spreads. Eventually, the old crust, though, will go back into the mantle at a trench or subduction zone.
Ash high into the stratosphere, hot spots 1 to 12, hydrothermal forces.
When we think of seafloor spreading, I want you to think of a conveyor belt. In this case, when the bottom of the seafloor is moving, what's on top? Well, the continents are moving. So when the seafloor is spreading apart, then the continents are going to be moving along with it. Seafloor spreading explains continental drift. The reason why continental drift was rejected back in the 1900s was because Alfred Wegener didn't have any proof as to why the continents actually move. What seafloor spreading does is it acts as proof to show why continents move. The continents move because the seafloor is spreading apart at the mid-ocean ridge, and as it spreads apart, it's carrying the continents along with it. So let's all fill out the diagram on the next page using the key terms. Make sure you number 6 through 15 each term you use so you don't forget one. To review, remember the mid-ocean ridge is the underwater mountain chain. A trench is an underwater canyon. A rift zone is the area where the plates are moving apart. Subduction zone is an area where a plate is going back under into the mantle. Something new that we haven't seen before on this particular diagram is it says to label 2 different types of plate boundaries. Remember, plate boundaries can either be divergent, convergent, or transform. Number 16. What type of volcano typically forms from subduction? If you remember, we covered this in class on Tuesday. Do I see any hands out there? Yes. You, thank you for raising your hand and being respectful. Yes. Did you say composite or stratovolcanoes? Yeah, that's right. It is composite or stratovolcanoes form at subduction zones. This is because when the crust sinks back under another in the subduction zone, it goes into the mantle where it melts again. And what we call melted rock, magma. And that magma can become fuel to make a composite or stratovolcano. The example we're going to look at is Mount St. Helens, which famously erupted in 1980 in Washington State. Mount St. Helens erupted on May 18th, 1980. It's about 30 years ago, and it was actually one of the most destructive volcanic eruptions in the history of the United States. This is 1980, so this is not like the time of the dinosaurs. This is when society, the United States, was in full swing. As a result of this eruption, 57 people died, 250 homes got destroyed, 47 bridges got destroyed, railroads. There's a lot of destruction. So imagine if the same thing were to happen to us today. As we know, we live in the Pacific Ring of Fire, and we also live among some of the most active volcanoes in the world. Number 18. Shield volcanoes typically form at divergent boundaries and hotspots. Shield volcanoes can happen at divergent boundaries, like at the mid-ocean ridge, and also at a hotspot, like the Hawaiian Islands, where the plates are moving over a fixed hotspot, and you get an island chain, and you also get shield volcanoes. How do shield volcanoes erupt? Do they erupt straight up? Nope, that is a cinder cone volcano. Shield volcanoes get their name because they're flat and have not steep edges, kind of like a shield. Right? So shield volcanoes, they erupt by lava overflowing slowly. Just kind of bubbles up and overflows instead of exploding straight up. Because of this, we get two types of lava. Aa is faster moving jagged lava. And Pahoehoe is slower moving and has a smooth rope-like texture.
Really hot. Did you dip your hammer in that?
And that is the video lesson for science. The next page of your packet is for language arts. Read the directions carefully. We're going to practice transitions a little bit. You already have a lot to do for language arts, so you're not going to have a lot to do in this packet just to review transitions. Keep in mind, I will be checking for transitions and the overall smoothness and coherence of your essay when you turn it in on Monday. So your transitions should be from sentence to sentence when you're trying to make a point, give examples, and also transitions should be from paragraph to paragraph. So from your second body paragraph to your third body paragraph, you need to have a transition so that it's not two completely separate paragraphs and it flows very smoothly. Alright, so a typed copy of this paper, all 6 paragraphs, completely written out, is going to be due on Monday when you guys return. Have a great weekend. Happy Halloween. Be safe. And when you're out there knocking on doors, just keep in mind, I want you to always think about who's going to be behind that door. The lady or the tiger.